done with our undamped free vibration response. Now let's discuss ang damped nga free vibration response. So if you remember no, the auxiliary equation r squared plus c over mr plus omega squared is equal to 0, the auxiliary equation of DDE. So, dali lang yan po. Pangitan niya po na ito roots, no? By quadratic formula, R is equal to negative B or negative C over M plus minus square root of B squared minus 4AC over 2 times A or 2 times 1. So let's just simplify this. We have R is equal to negative C over 2M plus minus, so ako lang i-distribute si 1 half na sa 2 plus minus 1 half square root of C over M squared minus 4 omega squared. Okay? Ako lang ipagawas ng si 4. We have negative C over 2M plus minus 1 half square root of 4 times C over 2M squared minus omega squared. So, padayon ta, we have R is equal to negative C over 2M plus minus 1 half times 2, because the square root of 4 is 2, times square root of C over 2M squared minus omega squared, or we will have R is equal to negative C over 2M plus minus square root of C over 2M squared minus omega squared. Now, for this one, aron dali atong life, na ko idugang kuan, na ko idugang variable or kuan kanang let's say we have our psi, no? Psi. The psi is our damping ratio. So this is equal to the damping coefficient over the critical damping. So unsa man ning critical damping? So ato lang, no? Simple, we have psi is equal to damping coefficient. If you remember, that is C over CC. So let's say our CC is the critical damping, and CC or the critical damping is equal to 2m omega. Now let's apply psi in this equation or the root. So we have R is equal to, so to we have negative C over 2m plus minus square root of C over 2m squared minus omega squared. Applying si psi, we have negative psi omega plus minus square root of psi omega squared minus omega squared. For R is equal to negative psi omega plus minus square root of, we have omega squared times psi squared minus 1. Or simply R is equal to negative psi omega plus minus, you have omega square root of psi squared minus 1. Now, natay three conditions diri, no? Let's say we have case A. For case A, if the discriminant, no, si C over 2m squared minus omega squared is less than 0. So kung let's say or si C atong critical damping, atong damping coefficient is less than 2m omega, or ang atong psi is less than 1.0. So of course, kung ang discriminant, which is sulod sa square root sign, is less than 0, so may pasabot. that is complex, no? Not a I. So, in this case, mo na siya ginatawag na tog under damp. So, lahat to si undamp o si under damp. So, under damp, kung ang discriminant is less than 0 sa ato pa, negative is square root. So, ang ato ang roots, equal to negative psi omega plus minus omega. And then, negative square root man ang sulod. So, let's take out the negative square root, negative 1. And then, we'll have 1 minus psi squared. So, bahay mo na lang din siya og r is equal to negative psi omega plus minus I omega square root of 1 minus psi squared. Now, we are gonna let omega d is equal to omega times 1 minus psi squared. Kung si omega tong natural frequency, si omega, we call this our damp natural frequency. So for case A, ang ato ang root will become negative psi omega plus minus I omega d. Okay, let's proceed. So for case A, batong root is equal to negative psi omega plus minus I omega d. Now if we substitute this sa atong kuan, general solution will have g1 e to d negative psi omega plus I omega d times t, and then plus g2 e to the quantity negative psi omega minus I omega d times time. Kung ato lang na i-distribute, we'll have e to the negative psi omega t plus I omega d t plus g2 e to the negative psi omega t minus I omega d t. Now, kabalo mo tanong sa property ani sa exponent ni e lugar, di ba? Nga ang e to the a times e to the b is equal to e to the a plus b. So this one, pwede natin siya mapaatras. So by applying that concept, pwede na nato mapagawas ang common nila na si e to the negative psi omega t times g1 e to the I omega dt plus g2 e to the negative I omega dt. Now, applying similar steps as before, no? The Euler's equation, we have e to the positive negative I omega dt. So this will become cosine omega dt plus minus I sine omega dt. So we just substitute this sa atong equation. We will have that u of t is equal to e to the negative psi omega t times we have g1 times cosine omega dt plus I sine omega omega dt plus g2 times cosine omega dt minus I sine omega dt. Or u of t, of t is equal to, ato siyang i-distribute, no, will arrive with this. I will have g1 plus g2 cosine omega dt plus g1 minus g2 for a while times I sine omega d t. So same application as before, no? At t is equal to 0, atong deformation at 0 is equal to u naught, and our response velocity u at time is equal to 0 is u dot naught. So applying this, no, um we have u naught is equal to e to 0 times we have quantity g1 plus g2 cosine 0 plus g1 minus g2 I sine 0. Or simply, we'll have g1 plus g2 is equal to u naught. Let's say, this is our equation 1. Okay, let's proceed. So, nanatay, next is u dot of t is equal to, so ato lang to i-differentiate si equal no u of t. So, ako lang i-relate on, lang ko to si u of t. We have u of t. So, this is the u of t, and the derivative, or the first derivative of u of t is equal to, so applying the product rule, no, we have the, let's say, na e to the negative psi omega t. Kung na to tong sa sulod, we'll have negative omega d times g1 plus g2 sine omega dt plus omega d times g1 minus g2 I I cosine, we'll have I cosine omega d t. So plus, so kato na song isa, we have the g1 plus g2 cosine omega d cosine omega dt plus g1 minus g2 I sine omega dt times negative psi omega e to the negative psi omega t. So kung yung tanawon no, si u of t, similar siya ani, tanawon, we have the e to the psi omega t and also this value. So sa ato pa si u dot t, the response velocity is can be written, and we have negative psi, so it can be written in this form, e to the negative psi omega t times we have the omega d times quantity negative g1 plus g2 sine omega dt plus g1 minus g2 I cosine omega dt minus psi omega of t. Now, applying tong kuan nga to initial value na to, that at time is equal to 0, u dot of t 0 is equal to u dot naught. So nata u dot naught is equal to e to the 0 times omega d times negative g1 plus g2 will have sine 0 and plus quantity g1 minus g2 I cosine 0 minus psi omega u naught. So sine 0 is already 0. Now we are left that u dot naught is equal to omega d times g1 minus g2 I, or I omega d times g1 minus g2 is minus psi omega u naught. Or if we rewrite, we'll arrive that g1 minus g2 is equal to u dot naught minus psi omega u naught over I omega d. Let's say this is our equation 2. Now, this is our equation, a general solution sa equation ng motion na to. And applying equation 1 and equation 2 na to, and then eventually we'll get that the general solution for the under damp condition, u of t is equal to e to the negative psi omega t times u naught cosine omega dt plus u dot naught minus psi omega u naught over I omega d times I sine omega dt. Now, ang kaning I na to, makancel na to. And eventually, atong u of t is equal to our general solution for the differential equation. Sa under damped condition, we have e to the negative psi omega t times quantity u naught cosine omega dt plus u dot naught minus psi omega u naught over over omega d times sine omega dt. So this will be our general solution for the under damped free vibration response. Now, how about for other case? So, napatay other case, diba? We have our case B. So, for case B, ang atong discriminant daw is equal to 0. Or our C, or damping coefficient C is equal to critical damping nga, 2m omega, or our psi is equal to 1.0. So, in this condition, we call this the critically damped nga free vibration response. Now, looking again at the roots of our auxiliary equation, when this is equal to 0, ang roots na to R will become equal to negative psi omega. And since psi is 1, we will have R is equal to negative omega. Now, in this case, the general solution is u of t is equal to g1 e to the negative omega t plus t g2 e to the negative omega t. And our general solution will become u of t is equal to negative omega t times quantity u naught plus t times u dot naught plus omega u naught. So this is our critically damped. So wala na nako gisyo kay taas na sa din kayo. And then for our last case, case C, when our discriminant, so mon siya, may tabon siya if our discriminant is greater than 0. So that is quantity C over 2m squared minus omega squared is greater than 0. Or ang ato ang damping coefficient is greater than the critical damping ato m omega, or kung atong psi is greater than 1.0. So ang roots atong auxiliary equation will be this one. And if we substitute that with our general solution, diba, we have g1 e to the r1t. So r1 denotes the root 1 plus we have g2 e to the r2t. Now, as you can see, no, there is no imaginary dire, therefore we cannot apply the Euler's equation na din dire. And eventually, we will arrive at the general solution for overdamp nga e to the negative psi omega t over 2 times quantity u naught times quantity e to the omega t square root of psi squared minus 1 plus e to the negative omega t square root of psi squared minus 1 plus u dot naught over omega square root of psi squared minus 1 times quantity e to the omega t square root of psi squared minus 1 minus e to the negative omega t square root of psi squared minus 1. And then eventually this will be the general solution for our overdamp na so man siya. So as you can see no nga from the general equation of motion nga second order differential equation and applying the concept of free vibration where our dynamic force is equal to 0, no we yield four general solutions. So katong four general solutions will be used in order to describe the motion of our one-story building. So with that, we'll be able to describe its deformation and also its response velocity and probably its response acceleration. Okay, so that's all for this discussion, the advanced engineering math for our assignment 1. And I hope na kuan sa tulong ko explain. Thank you and have a great day ahead.